Okay, in this question, we're going to calculate the expectation value and the variance of the uniform probability density function. Okay, so just to remind you what the uniform probability density function is, it's that the function f of x is equal to 1 over b minus a as long as, oops, let me redo that, 1 over b minus a as long as the variable lands between a and b, and it's 0 otherwise. Okay, so this is just a standard uniform probability density function. So what we would like to do is calculate the expectation value and the variance of the uniform probability density function. So the expectation value is sometimes denoted by mu. Also, it could be e of x. And the way to calculate that for any probability density function is we would like to integrate from negative infinity to infinity, so to consider all possible values of the continuous random variable. But we would like to take x and multiply it by our probability density function. Okay, so that's for any probability density function. So let's actually do it for ours. This is going to be, let me rewrite that. So this is for any probability density function. So let's do it for ours. So if we notice here, what is our f of x? Well, it's 0 anytime we're talking about x's that are not between a and b. So whenever the next value is not in between a and b, the function f of x is just 0. So it wouldn't contribute to the integral at all. So rather than integrate from negative infinity to infinity, we're only really going to have to integrate from a to b. Because if x is outside of a to b, then f of x is just 0. So we only have to really worry between a and b, and we have x, and what is our function when x is between a and b? Our function is just 1 over b minus a, so this is 1 over b minus a dx. So this is f of x in here, so let's go ahead and calculate that. We can pull out the 1 minus b over a, that's just a constant, that has no x's in it whatsoever, and we can just do the integral from a to b of x dx. If we go ahead and calculate that, we have this 1 over b minus a that is sitting on the outside. We will get the antiderivative of x is 1/2 x squared, and we're going to evaluate that from a to b. That becomes 1 over b minus a. We're going to plug in b, so that gives us 1/2 b squared, and we're going to subtract off what we get when we plug in a, 1/2 a squared. So if you work that out, that becomes 1/2 1 over b minus a times b squared minus a squared, which we can write as 1/2 1 over b minus a, b minus a times b plus a. And we can see here that this b minus a will cancel out with this b minus a, and so we're left with that the expectation value of the uniform probability density function is 1/2 b plus a. Okay, so that's the expectation value of the uniform probability density function. So let's calculate the variance now. The variance is given var x. So the variance is calculated in the following way. It's the integral from negative infinity to infinity of x squared times our probability density function. And then at the end, after doing that integration, we're going to subtract off the expectation squared. So that's just the general formula for the variance. And so now let's actually do it for our case. Again, because our function f of x is only non-zero when x is between a and b, we only really have to carry about doing this integration between a and b. So rather than do the whole integration from negative infinity to infinity, we only have to care about going from a to b. So here's our x squared. And in this region, what is our probability density function? It's just 1 over b minus a dx. And for now, I'm just going to leave this as the expectation squared. Of course, we calculated the expectation already, but I'm just going to leave that out for now. Okay, so let's carry out this integration. We can pull the b minus a out front because it is just a constant as far as x is concerned. This is the integral from a to b of x squared dx. And of course, we still have this minus the expectation value squared. The antiderivative of x squared. The antiderivative of x squared is, of course, 1/3 x cubed, and I'm going to substitute in a and b. And then I'm going to subtract off mu squared. So at the end of the day, this becomes 1 over b minus a times, if we substitute in b, we get b cubed. And then if we substitute in what we get, if we substitute in a, we get 1/3 a cubed. Of course, if we should subtract off the mean here. And so we can bring this 1/3 out front. This becomes 1 over 3 times 1 over b minus a times b cubed minus a cubed. So that's the first part, minus what was our mean value? What was this mean value that we calculated up here, or this expectation value? 1/2 b plus a. So this becomes minus 1/2 b plus a squared. I'm sure if you wanted to, you could probably simplify this a little bit, but I'm just going to leave it like this so you can kind of see how this form comes about.